Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing. down there.
Welcome to today's lesson for Natural Sciences. We are still looking at term 3, and the knowledge area is still energy and change. Now, I'm sure by now you know that this section contributes 80 marks towards your final examination, so please pay attention and take advantage of the marks because they are relatively very easy to get. Today's topic is series and parallel circuits, and the subtopic is series circuits. By now you know my name is Kwanele Dlamini, and this lesson is proudly brought to you by the Gauteng Department of Education. So without any waste of time, let's get right into it. So what's the point of this lesson? What are we trying to achieve? We are trying to ensure that by the end of this lesson, you should be able to explain that the total voltage across the battery is equal to the sum of the voltages across each of the resistors in a series circuit. You should be able to explain that the total voltage across the battery is equal to the sum of the voltages across each of the resistors that are connected in series. You should also be able to explain that a resistor with a high resistance will have a high voltage across it. You should be able to explain that a resistor with a high resistance will have a high voltage across it. You should also be able to explain that a resistor with a lower resistance will have a lower voltage across it. You should also be able to state that the current is the same when measured at any point in the circuit of a series circuit. You should also be able to state that the current is measured using an ammeter. And you should also be able to explain that ammeters are always connected in series because they have a low resistance. And lastly, you should be able to explain that the current in a circuit decreases with every resistor that is added in a series circuit. For more information on this, you can refer to the grade 9 CAPS document on page 73. Let's continue. Now let's take a step back and look at pre-knowledge, which is nothing but what you've already studied or learned in previous grades. So we're going to take a step back and brush up on the concepts that you already know. Right, so from grade 5 and 6, you learned about electric cells. But what are electric cells, or what is an electric cell? An electric cell is a system in which certain chemical reactions can cause the flow of electricity or current through an external circuit. So it's a system in which there are certain chemical reactions that are occurring which can cause the flow of what? Electrical current or electricity. Right. Now, we use this kind of cells. This is a AA 1.5 volt cell. We use these ones in most applications when we are doing electric circuits, either series or parallel. So we can choose to connect these ones in series or in parallel. We can connect the cells either in series or parallel. When we connect them in series, the voltage is additive. We add the voltage provided by each of the cells to get the voltage of the battery. Remember, a battery is made up of 2 or more cells that are connected together. But then we can also connect them in parallel. It gets a bit tricky when it's parallel, but in most cases we don't usually use parallel cells in our circuits. But for interest's sake, I will explain how they work. So in a parallel connected battery, the total voltage of the parallel network is equal to the voltage of one cell. So in other words, if you have 2 cells which are 1.5s, your parallel voltage is going to be 1.5. It doesn't change when they are connected in parallel. But you won't see that in most applications from grade 9, 10, 11, and 12. Maybe at varsity level, you will see cells that are connected in parallel. Let's continue. Then in grade 6, we learned about mains electricity. But what is mains electricity? This is nothing but the electricity that is delivered to our homes for our domestic use, the electricity that we use at home every day. And we use this device to control it. Right. This is a very important component of the electricity in a household. Why? Because it helps us to control and to keep ourselves safety when there is a poor connection or a problem with the circuit. This is called a DB board, and we can trip the switches there to protect ourselves, or sometimes it trips itself if there's a problem to prevent the house from burning. So this is a very important component, but it only works for one household. Your neighbor has their own. Actually, every household has its own DB board. Right. In grade 7, we learned about the National Electricity Supply System. But what is the national electricity? You can think of this as the distribution of electricity from the power stations and all the steps that are involved until it reaches our households. So we burn coal from the power station. Okay, coal is delivered from a mine and then it's burned to heat up steam, and that steam is used to provide energy for a turbine, and the turbine turns a generator. The generator makes electricity, and then from there we put it on a step up transformer to increase the voltage, and then we transport it with our transmission lines or power lines into a substation where it is stepped down, and then it goes into our households so that we have the required amount of electricity. So this is the whole system, the national grid, from the power station all the way to what? All the way to the end user, which is our households. Then in grade 8, we learned about energy transfer in electrical systems. What are the energy transfers that occur in electrical systems? Can you think of any one of the energy changes? Well, I can give you a few. From when we're burning coal to burn steam, the energy transfer that, okay, the coal burns steam, and then the steam turns a turbine to, then the turbine turns the generator generates electricity. So the entire energy transfer there is from thermal or heat energy into electrical energy, right? That's the overall energy conversion there. Then when the electricity reaches our homes, depending on the application that you are going to use it in. For instance, if you're lighting a light bulb, you are converting electrical to light energy and heat energy because the bulb is going to have some form of heat. And then if you are turning on a stove to cook your food, you are converting electrical to heat energy, right? And if you are going to plug in your radio or your television, there's going to be sound energy, okay? So you are turning electrical to sound energy. So those are the different kinds of energy transfers that occurs in electrical systems. There are more, but for the purposes of this lesson, I'm just going to stick to those few that I gave you. Let us continue. Now let's do a baseline assessment just to assess how much you understand of the concepts that we are learning or the concepts that are related to today's lesson. So the first question says, is a voltmeter connected in series or parallel, and why is it so? Number 2, explain what happens to the current in a series circuit when we add more resistors. Question 3, what is the unit of measurement for current? And lastly, define resistance. So you have 4 minutes to work on these 4 questions, and your time begins now. Welcome back, learners. I hope you were able to work through those 4 easy questions. Now, without any waste of time, let's discuss the answers together. So the first question was, is a voltmeter connected in series or parallel, and why is it so? What is the answer? Yes, that is correct. A voltmeter is connected in what? In parallel. But why is that the case? That is because a voltmeter has a very high resistance. So if we were to connect it in series, it would not allow current to flow through. Remember, resistance and current, they are inverses of each other. The higher the resistance, the least amount of current that can flow through. So if we were to connect the voltmeter in series, there would be no current flowing because it has an insanely high resistance. So that is the reason why we connected in parallel. Okay. Question 2, I hope you were able to get that one correct. Number 2, explain what happens to the current in a series circuit when we add more resistors. Anyone? Yes, that is correct. The current will decrease. Why will the current decrease? That is because when you increase your resistance, the current strength of that circuit will decrease. Remember, the battery has to provide more energy or more voltage to overcome this resistance, and hence the current is going to be low. Okay, I hope you got that one correct. Now let's look at number 3. What is the unit of measurement of current? I'm sure everyone got this one correct. Yes, that is correct. It is what? The amperes with letter A, capital letter A, right? This is the unit of measurement for current. And lastly, define resistance. Now, I'm sure everyone from our previous lesson, you should know what resistance is. What is resistance? Yes, that's correct. It is a force or the tendency of an object to of a conductor to oppose the flow of current through it. It is the opposition in the flow of current. Okay. Now let's continue with the lesson. Let's define a couple of terms that we are going to use in the lesson so that we don't need to consult Google or the dictionary. We don't need dictionaries. Let's just define it now so that when we see it, we completely understand what it means. The first term we are going to define is a series circuit. What is a series circuit? A series circuit is an electric circuit that only has one pathway for current to flow through. It's an electric circuit that has only one pathway for current to flow through. Once it has more, it's no longer a series circuit. It's something else. Current. What is current? Current is the flow of electricity or charge through a conductor. It is the flow of electricity or charge through a conductor. So the flow of charge generates current in a conductor. Okay. An ohm. What is an ohm? An ohm is the unit of measurement for resistance. Okay, it has the symbol, the Greek symbol omega. That is the unit of measurement for resistance. Potential energy is energy that is stored in a system. An ammeter is an instrument which we use to measure what? Current. An instrument for measuring electric current in amperes. Okay. Now, let's begin with our lesson. Connecting resistors in series. So we know that resistors can be connected in series or parallel, which we are going to talk about next week. But for now, let's talk about series. We can connect resistors in series. But what is a resistor? A resistor is a material or a conductor that opposes the flow of current through it. Okay. So a light bulb is an example of what? Of a resistor. Remember from our previous lesson, we said that light bulbs, rheostats, and motors, electric motors are examples, just to name a few, of resistors. The unit of measurement for resistance is the ohm, and a series circuit would look like this. You have your power source, which is your battery or a cell. Remember, we call it a cell if you have one, and we call it a battery if you have more than one. So you have your battery. When you connect it there, all these light bulbs are going to glow, but then when you disconnect, they all don't glow. Why is that the case? That is because there's one pathway for current to flow through. So it's a series circuit because it has what? Only one pathway for current to flow from the battery to the first bulb, which is a resistor, to the second one, and all the way to the other side of the battery. So when you disconnect, nothing flows. When you connect, there's going to be glow. Okay, and then in a circuit diagram, it looks like this. Okay, a bulb is represented with the circle with an X inside, and then the battery is represented by these symbols. I'm sure you remember this from grade 8. And then this clamp here will represent, this connecting wire will represent a switch, right? So when you open it, when you disconnect, the circuit becomes open. It's like an open switch. And then when you close, it becomes a closed circuit and current can flow. When it's open, there's no current flow. That's why the bulbs are not glowing. But then when it's closed, it's a complete circuit and current can flow. Let's move on. So the total voltage across the battery is equal to the sum of the voltages across each resistor in the circuit, right? This is only applicable to a series circuit. The total voltage that the battery provides to the external circuit is going to be split amongst each of the resistors. In other words, when you add the voltage across each of the resistors that are connected in series, they should give you the total voltage that's supplied by the battery. Okay, so this is basically an illustration of what I just explained. The battery supplies 6 volts. You have 2 resistors. The resistors are going to split these 6 volts according to their resistance, right? If they have an equal resistance, both of them, these 2 resistors, they will split the voltage equally. But if they don't have an equal resistance, they will split it according to which one has the lowest resistance and which one has the highest resistance. Okay, the one with the lowest resistance will get the lowest voltage, and then the one with the highest resistance will get the highest voltage. Why? Because it needs more energy to overcome the resistance of that particular resistor. So the higher the resistance, the higher the voltage, and then the lower the resistance, the lower the voltage. Okay, let us continue. So this is a circuit diagram that represents a series circuit. So in this circuit, we have 3 cells that are connected in series to give us what? A battery. So the voltage of the battery is going to be the voltage of the first cell plus the voltage of the second cell plus the voltage of the third cell. Okay, that gives you what? VT, which is the total voltage from the battery. And it's going to be measured by a voltmeter, which is connected in parallel to the battery. Okay, this is parallel. Okay, a voltmeter is always connected in parallel to any component that you're trying to measure voltage from. And then you have your first resistor. We connect the voltmeter in parallel. Okay, this is V1. It measures the voltage across the first resistor. This is R1, resistor 1. Then you have resistor 2, and then again, if you want to measure the voltage across resistor 2, you connect it on the ends. You don't connect it in series with this resistor because there won't be current won't flow. So you connect it in parallel. This measures voltage across resistor 2. And then this is supposed to be an ammeter. There's a mistake here. It's not a V. We never connect a voltmeter in series. We always connect it in what? Parallel. But an ammeter is connected in series. Why? Because it has a negligible amount of resistance. So it allows current to flow through. It doesn't affect the flow of current. So this is an ammeter. It measures the current that's flowing through the circuit. Now, if we take this same ammeter and we put it this side, it should give us the same current that it gives us there, provided we are keeping our resistance constant. If we add another resistor, the ammeter reading will change. It will drop actually. Why? Because we are increasing the resistance of the circuit. Okay, but if we are keeping the number of resistors, which gives us the resistance, constant, the current reading will be the same from ammeter 1 to ammeter 2. Okay, but if we add more resistors, like if maybe we add a third resistor there, then the ammeter reading, yes, will be the same, but it will drop. Okay, and one more thing, the voltage across the first resistor plus the voltage across the second resistor gives us the total voltage from the battery. Okay, so V1 plus V2 gives us V total, which is the total voltage from the battery. Why? Because we said we split the voltage amongst the resistors. This is resistor 1, resistor 2, V1 is here, V2 is there, and they give us Vt from the battery. Okay, let's continue. So a resistor has a high resistance. A resistor that has a high resistance will have a high voltage across it. Okay, remember voltage is directly proportional to resistance. So if you have a high resistance, you need a higher voltage to overcome that resistance for current to flow through. Okay, so a high resistance will have what? A higher voltage across it. And of course, a resistor that has a lower resistance will have a lower voltage across it. Why? Because it requires less energy to overcome the resistance, because the resistance is low. But if the resistance is high, we need higher voltage. Okay, I hope that makes sense. The current anywhere in a series circuit will be the same, but there's a condition. For the current to remain the same, the resistance must be maintained the same as well, because if you increase the number of resistors, you are increasing the resistance, and hence the current will drop. Okay, it will be the same at all the points around the circuit, but it will decrease if you add more resistors. But if you keeping the resistance constant and you measure the current on different points in the circuit, it's going to be the same. The current in the circuit decreases with each resistor that is added. Okay, as I've already explained, the more you add resistors, you are increasing the resistance of the circuit, and hence more energy is used to overcome that resistance, and hence less current will be delivered. Okay, we can measure current using an ammeter, right? The unit of measurement, okay, the instrument for measuring current is an ammeter. So we use the ammeter to measure the current that's flowing in the circuit. And remember, the ammeter is always connected in what? In series. And the unit of measurement for current is what? Amperes, with the symbol A. Okay? So an ammeter is always connected in series because it has a very low resistance. Okay? It doesn't affect the flow of current. So if you connect an ammeter in parallel, it would not work. Okay? But if you connect it in series, it will work and the current will flow. Right. So this is an illustration just showing you how to connect an ammeter in a series circuit. Okay, it's always connected in series anyway. So this is your cell, 1.5 volts, and you have, let's see if it's a series circuit. There must be one pathway for current to flow from one terminal of the battery to the other terminal. So current can flow from here into the ammeter, and then it flows on the other side to the bulb all the way back to the cell. So there's one pathway for current to flow. This means it's a what? A series circuit. Okay, if we disconnect any of the conducting wires from any component in this circuit, there will be no current flowing. That's what we mean by a series circuit. There's one complete pathway, and if you remove one of the conducting wires, then there won't be any flow of current. And then in a circuit diagram, it will look like this. This represents the cell, that symbol over there, and it gives us what? Voltage. And this is your resistor, which is the bulb. Okay, this is your ammeter with the symbol A. Whenever you see a circle with an A inside, it represents your ammeter. So this is the ammeter, and that's basically your whole circuit. Then this represents the flow of current through the circuit. There's one pathway. And if we remove either this side, this connection, there won't be any flow of current. If we remove this connection, there won't be any flow of current. Even if we remove this side, there won't be any flow of current. That's what a series circuit is. Okay. So ammeters, we have two kinds of ammeters. We have analog ammeters, and we also have digital. Sorry, we have analog and digital ammeters. Right. This is an illustration of an analog ammeter. An analog ammeter has something that looks like a clock. It's a meter, actually. You have a meter, and inside the meter there's a needle that moves from 0 all the way towards any number that's given there. So you interpret the result by reading where the needle is located within this ammeter. So when it's at 0, that means there's no current flowing, obviously. And then when it's at any number that's not 0, that gives you the current that is being measured. Okay? So there are issues with an analog ammeter because you have to read the values yourself. There's a chance that you may make mistakes, and hence we prefer to use another form of an ammeter which actually gives you an exact value. Not saying that analog ammeters are not good, but they are excellent. You just need to be careful when you're reading your values because you may make mistakes due to human error. But we prefer to use digital ammeters. Why? Because digital ammeters, they don't have a needle that you have to try and read and estimate a value where it's at, especially when it's like in between two numbers. It becomes difficult to read. But for a digital ammeter, you see the exact value of your current. If maybe there's 2.15 amps, it's going to give you that exact value, but it's difficult to read that from this analog meter. Okay, so in most cases we prefer this digital one because it gives you the exact value. You don't have to try and read it yourself. Okay, so an electric circuit is a closed path that electrical energy can flow through. Okay, and a series circuit provides only one pathway for current to flow such that all the components are connected by one line. Okay. Cells or resistors can be connected in series in a circuit, right? We said that when we connect cells in series, we add the number, okay, we add the voltage provided by each of the cells to give us the total voltage. Okay. Now let's do a couple of questions just to test whether we understand what we've done so far. The first question is, what do we know about the current strength at any point in a series circuit? Oh, sorry, I already showed you the answer. What do we know about the voltage across the battery of a circuit with resistors connected in series? Okay, I've already given you the answer for the first question. It's up now. You can work on the second one. What do we know about the total voltage across the battery of a circuit with resistors connected in series? You have one question. 1 minute should be enough for you to work on this question. And you are very welcome to discuss with your friends. All right, learners, welcome back. I hope you were able to work through that easy question. Before we discuss the answer to this question, I would like to quickly remind you about our WhatsApp line. If you have a question or if you need clarity on anything that we have discussed today. You can send your question through to 064 748 8913. That's 064 748 8913. Send your question there and we will kindly assist you. Right, so let's answer the question. What do we know about the total voltage across the battery of a circuit with resistors connected in series? Anyone? Yes, that is correct. The total voltage across the battery of a series circuit, of a circuit with resistors connected in series is equal to the sum of the voltages across each of the resistors, okay? The total voltage of the battery is equal to the sum of the voltage measured across each of the resistors connected in series. In other words, resistor 1 and resistor 2 or resistor 3. When you add the voltage across each of those resistors, they should give you the total voltage from the battery. Okay. Now, let's take a break to do a practical demonstration. Let's take a 2-minute break and then we will do a practical demonstration which has an activity. So it's an activity which is embedded with a practical demonstration.
You are responsible for your own life, no matter how old you are. You are responsible for the things that are currently happening in your life right now. Nobody is going to push you to become a better student. Nobody is going to push you to read more, to study more. You are responsible to put in the time necessary so that you can get the results that you want in your life. So today, make sure that you are putting in the work. Make sure that you are responsible in doing everything that you want to do. Because for you to achieve more, you need to put a little bit extra work to what you are doing and keep on believing. Keep on believing and keep on doing, and you will see the success that you want. You are responsible for your own life, no matter how old you are. You are responsible for the things that are currently happening in your life right now. Nobody is going to push you to become a better student. Nobody is going to push you to read more, to study more. You are responsible to put in the time necessary so that you can get the results that you want in your life. So today, make sure that you are putting in the work. Make sure that you are responsible in doing everything that you want to do. Because for you to achieve more, you need to put a little bit extra work to what you are doing and keep on believing. Keep on believing and keep on doing, and you will see the success that you want.
All right, learners, let's quickly do our practical demonstration. So the instruction says, copy the table below and answer the questions that follow. So you have a table. In the first column, you have to record resistor number, resistor 1, 2, and 3. Then you have resistance in ohms for all those resistors. Then you have voltage across the resistor, which is in volts. Then you have ammeter reading after each resistor, which is recorded in amps. Then you have the total voltage across the battery. Right, so you are going to set up a series circuit with 3 resistors in series and 4 1.5 volt cells, which gives you a total of 4.5 volts. Right, so right in front of me, I have a circuit board. And on this circuit board, I have 1, 2, 3 resistors that I need to connect in series. And I have a digital voltmeter, a digital ammeter, connecting wires, and a battery. Remember, a battery is made up of 2 or more cells that are connected, right? So let's quickly connect the first one and record. We are going to fill in the first row, actually the second column, where we fill in the resistance, right? But the resistance, each of these resistors has 1.5 ohms. So we can just fill in 1.5, 1.5, 1.5 for all those throughout that column. Then the second one, we are going to take the voltmeter reading when we connect each of these resistors. So let's quickly do that. Okay. So we've connected the first one, and I'm going to turn on my digital voltmeter and take the readings. So the readings, when I connect the first resistor, it gives me a value of 4 1.5 volts. Let's quickly write that down. So we have 1.5, 1.5, 1.5. All these resistors are equal in resistance. So the voltage for the first one is 4.03. That's the voltage across the first resistor. Now we are going to connect another one. Remember, in a series circuit there must be one pathway for current to flow. You don't need branches. So let's quickly connect the second one. Right. Okay. My circuit board is acting up. Right. And the voltage is increasing to 4.08. Okay. Right, let's connect the third one quickly. This is the third one, and as you can see, I have one pathway for current to flow. So you can't really see the glow of the second one, but we do know that there is a flow of current because the first one is glowing and the third one is glowing, and there's one pathway, so that should be fine. So we have the voltage reading is 4.09. Okay. Now we are going to need to record the current readings. Okay, let's quickly connect our ammeter. Right, we connect our ammeter in series with all of these resistors. So we will start with the first one here. Okay. So we are going to connect this here and this one there, right? And we are getting a current reading of 0.32 amps. Right, that's the current reading at point 1. Now let's connect it at point 2. We are going to move this to this point and we connect this one there. It's 0.23. 0.23. Then we go to the last one, the last position. Right. Connect this there and this one there. It drops down to 0.18. Okay. And let's disconnect everything and take the voltmeter reading across the battery. Okay. That is 4.15 volts. Right. So this is the end of the recordings. I'm going to read the recordings for you so that you copy them into your table, because we are going to need this to answer the questions that follow. So the first resistance for resistor 1 was 1.5, and then the second one 1.5, the third one is also 1.5. And then the voltage reading, when we connected the first resistor, it was 4.03. When we connected the second one, it was 4.08, and then when we connected the third one, it was 4.09. And then the ammeter reading across each of these resistors, when we had one resistor, it was 0.32. And then when we connected the second one, it was 0.23. And then the last one, it was 0.18. Then the voltage across the battery when nothing else is connected was 4.15. So we are going to need these results in order to answer the questions that follow. All right, learners, welcome back. I hope you enjoyed that practical demonstration. Although there was a mistake that was conducted during that experiment. Let me just quickly highlight what went wrong. The voltage was not recorded for each of the light bulbs. It was only taken across the battery, but everything else was fine. So I'm going to provide you with a table with all the answers that you need. Sorry for that. So we had to copy the table, and I'm sure you did that. And then you set up a series circuit with 1.5 volt batteries, and you have 3 resistors, a voltmeter, and an ammeter. Right. So we've done this part of the exercise, let's just jump on to do the questions. Right, so this is the table where you need to fill in your results. So when I conducted the experiment, I measured the current for each of, after adding each of the resistors, right? So when you have one resistor, you have a current value, which is different to the one you have when you have two resistors, yes. And then which is also different when you have three resistors. But the column for current in the ammeter reading after each resistor needs the total current after adding all three resistors. So because of the error that we made with the voltmeter reading, I will just give you the values as they are. So we're going to begin with the voltage. Okay, we're going to start with the ammeter readings, which is column 1, 2, 3, 4. The total current of that circuit before we connected everything is supposed to be 0.5 amps, which remains the same throughout after connecting all three. And then the total voltage that was measured before we connected anything was 4.5 volts. Okay, and then the resistance, if you paid attention to what was happening with the bulbs, the first one was glowing the brightest, the second one was very dim, and the third one was also bright but not as bright as the first one. What does that tell you? That tells you that the resistance of each of those resistors is not the same. So we may have made another error there. So I'm going to give you the correct values. The first resistor has 0.25 ohms. The second one has 1 ohm, and the third one has 2. So the voltage, we are going to calculate it using this information that's given. Okay. So the voltage across the first one was 1.5. The second one, 0. Okay, no, I'm lying. The voltage across the first resistor was, sorry, give me a minute. I'm just trying to work this out. This was 2.5. This was 0.5. 1.5, 2.5, 0.5, and then this was 2. Because when you add them, they're supposed to give you 4.5 volts. So the sum of the voltages across each of those resistors is supposed to give you the total voltage from the battery. My apologies for the error that was conducted there. But that's not a train smash. We can still answer the questions. So number 8 says, compare the added voltages across each resistor to the total voltage measured across the battery. What do you notice? Well, I will assist you with answering these questions because we made errors. Okay. So compare the added voltage across each resistor to the total voltage measured across the battery. What do you notice? Well, second question, what conclusion can you make about the voltage across the battery and the sum of the voltages across the resistors in a series circuit? 9, what did you notice about the current strength at any point in the circuit? 10, which resistor had the highest voltage? 11, which resistor had the lowest voltage? 12, what is the relationship between the resistance of a resistor and the voltage across the resistor? Right. So these are the questions that we are going to answer together because of the unforeseen circumstances. So let's quickly do question 8 together. We will do all the questions together. Compare the added voltage across each resistor to the total voltage measured across the battery. What do you notice? So the total, okay, the voltages that we added across each of the resistors gives us the total voltage that was delivered by the battery. So the voltages are going to be the same. When we add the voltage across resistor 1 to the voltage across resistor 2 and the voltage across resistor 3. They give us the total voltage that was delivered by the battery. So we're going to say Vt, which is from the battery, is equal to V1 plus V2 plus V3. Okay. The voltages across each of those resistors was the same as the total voltage from the battery. When you add the sum of those three voltages, they give you the total voltage from the battery. Number B, what conclusion can you make about the voltage across the battery and the sum of the voltages across the resistors in a series circuit? What conclusion can you make about the voltage across the battery and the sum of the voltages across the resistors in a series circuit? The sum of the voltages are adding to that of the battery. So when you add the voltages across each of those resistors, they give you the voltage from the battery, which is a characteristic of series circuits because we know them as what? Potential dividers. Why are they potential dividers? That's because they divide the voltage coming from the battery amongst themselves. When you add the voltage across each of them, gives you the total voltage from the battery. Okay, let's do question 9 together. What did you notice about the current strength at any point in the circuit? Right. The current strength across any point in the circuit is going to be the same, unless, of course, you add more resistors. When you add more resistors, you are increasing the resistance and you are weakening the current strength. So the current strength decreases when you add more resistors. But when the resistors are kept constant, as you saw with the experiment, when I was recording the current after adding each of those resistors, it kept on going down. Why? That is because we were increasing the resistance. And when you increase resistance, you need more energy to drive the current through that particular resistor. So the current that is now able to pass through is lower than it was when you had one resistor with a smaller resistance. Okay, I hope that makes sense. Number 10, which resistor had the highest voltage? Now, if you paid attention to the demonstration, you may have seen that one of the bulbs was glowing brighter than the others. Which bulb was that? That's what the question is asking for. Yes, it was the first one. The very first bulb was the brightest. So it's resistor 1. Okay? That was the brightest one. I hope you got that one right. Which resistor had the lowest voltage? Okay. This one was resistor 2. Okay. What is the relationship between the resistance of a resistor and the voltage across the resistor? What is the relationship between the resistance of a resistor and the voltage across a resistor? Okay, the relationship is that if the resistor has a high resistance, it will have a lower voltage. No, it will have a high voltage, sorry. And if the resistor has a low resistance, it will have a low voltage. Okay, so let's continue. Let's do 2 more questions and then we can go to your WhatsApp questions and sum up the lesson. What happens to the current strength when more resistors are added in series to a circuit? What happens to the current strength when more resistors are added in a series circuit? Question 2, what do you think will happen to the brightness of a light bulb if another light bulb is added in series? Okay, you have 2 minutes to work on those questions and your time begins now. All right, learners, I hope you were able to work through those two questions. Now, I'm very interested in your answers. But remember, if you have a question for us, you can send it through to the WhatsApp line, which is 064-748-8913. That's 064-748-8913. Send your questions through and we will kindly assist you if there's anything that you need clarity on. So the first question says, what happens to the current strength when more resistors are added in a series circuit? Okay. What do you think? The current strength will decrease. Why? Because we are increasing resistance. And current and resistance are inverses of each other. When you increase the other one decreases. Okay? So the current strength will decrease. What do you think will happen to the brightness of a light bulb if another light bulb is added in series? If you add more bulbs in series, what will happen to the brightness of the first one? Yes, that is correct. The brightness of the bulb will decrease. Why? Because it's the same as the first question. You are increasing the resistance by adding another bulb. So now the current strength will be decreased and hence the glow of the bulb will decrease because now the current is decreased. The overall current is decreased. More energy is used to overcome two components of resistors. Okay, two resistors. So the current will decrease. The brightness then will decrease. Okay, let's summarize our lesson. We said that a series circuit provides only one pathway for current to flow through. A series circuit provides only one pathway for current to flow. There's one complete pathway from one terminal of the battery to the external circuit and then back to the other terminal of the battery. Resistors can be connected in series in a circuit, just like what we did in our lesson. All our resistors were connected in what? Series. Okay. A light bulb is a type of resistor. We have many resistors out there as we've highlighted in our previous lesson, but a light bulb is a typical resistor that we see or use almost every day. And the unit of measurement for resistance is ohm, as we have explained in our previous lesson. The total voltage across the battery is equal to the sum of the voltages across each of the resistors, and hence we call resistors in series potential dividers because the voltage is shared amongst the resistors, but the total voltage is given by the sum of the voltages across each of those resistors. Resistors connected in series are potential dividers. Okay, they divide the voltage, and current flowing through the circuit is the same throughout. Of course, if we are keeping the resistance constant, but if we keep adding more resistors and measure the new current, it's going to be different from the one before we added another resistor. Okay, but at any point in the circuit, the current will remain the same if we are keeping the resistors the same. When additional resistors are added in series, the current strength will decrease while the total resistance will increase. Okay, I think I've explained this a lot of times already. So now let's take time to go through your WhatsApp questions and see what you have for us. Okay, okay, that's not for us. Okay, there's one question here. Definition of potential energy regarding grade 9 natural sciences. Okay. Potential energy can be defined as energy that is stored in a system. It's energy that it's not being used, it's stored in a system. Thank you for your question. Well, it looks like we don't have any more questions. So let's just go back to the lesson. Okay. So let's just do another brief overview of what we have done. We said that a series circuit provides only one pathway for current to flow. We can connect resistors in series, and when resistors are connected in series, they what? They divide the voltage. The current remains the same for as long as we have the same number of resistors. So when you measure your current throughout your circuit, it's going to be the same. Okay. And okay, now after finishing this lesson, what you need to do is you go to the bottom of your video. There's going to be a button that says complete and continue. Then you click there, and then you're going to get a message that says congratulations for finishing your lesson, and you will get bonus points. Okay, so now in our next lesson, we are going to be looking at parallel circuits. And I think it's going to be very interesting there because there's going to be more than one pathways for current to flow, unlike a series circuit which only has one pathway. We are going to connect resistors in parallel. We are not going to connect batteries or cells in parallel because we don't do that in the curriculum of grade 9, grade 10, 11, and 12. Maybe when you go to tertiary, you will see something like that. So thank you so much for joining me for this lesson. It's been a pleasure hosting you for a lesson in series circuits. I hope now you understand something or more about series circuits. And I hope to see you in our next lesson. And please remember to take care of yourself, wear your mask, sanitize your hands, and keep your distance, and keep safe until we meet again when we do our parallel circuits lesson. My name is Kwaneli Dlamini, and it's been a pleasure hosting you for this lesson. Thank you so much. This lesson was proudly brought to you by the Gauteng Department of Education. Thank you.